In the last few lessons, we learned all about what is algebraic expressions and how to evaluate them. So, in this lesson, we're going to be taking that skill a step further and learning all about whole expressions. And this as well would be our intro to polynomials, which we would be working with in some other units as well. So let's get started. This is our lesson today, whole expressions, and our learning goals would be understanding the concepts of monomials, polynomials, and integers through specific examples, and understanding concepts such as the coefficient and degree of monomials and the degree of polynomials. So here's an introduction. As shown in the picture, the track of a school is composed of a rectangle and two semicircles. 1. What is the area of both of the semicircles? Well, as you can see, if you put these two semicircles together, they form a circle. And we definitely know how to calculate the area of a circle. That's just going to be pi times the radius squared. And since b over here is our diameter, we just have to do b by 2, so that would be the radius. And then we will square that. So that's pi times b divided by 2 squared. Now 2. What is the area of the entire field? So the entire field would just be the area of this rectangle plus what we already have for over here for the semicircles. So that would be pi times b divided by 2 squared plus ab. These two formulas are both algebraic formulas. So what are the differences between these algebraic expressions? Right now, we are going to be taking a look into something called monomials. Fill in the blanks with expressions containing variables. 1. The surface area of a square with the edge length a is blank. The volume is blank. So how we would fill in the first two blanks would be with 6a squared and a cubed. It says that the surface area of a square with the edge length a is going to be 6a squared. Actually, no. It's going to be the surface area of the cube with the edge length a will have a surface area of 6a squared. This is going to be a cube, and is asking for an algebraic expression that would express the surface area of the cube. It's not the volume, it's the surface area. We know that it has 6 faces, and each face is a square. So that would be 6a squared. And the volume of that same cube would be a cubed. 2. The unit price of a pencil is X dollars, and the unit price of a ballpoint pen is 2.5 times the unit price of a pencil. The unit price of a ballpoint pen is blank dollars. If we know that the price of a pencil is X dollars, the ballpoint pen is 2.5 times the unit price of that pencil, that would just be 2.5x. 2.5 times X dollars. 3. The speed of a car is v kilometers per hour, and its driving distance of t hours is blank kilometers. We already know that it drives v kilometers per hour, and there are t hours. It's going to be vt kilometers. 4. The radius of a circle is r centimeters, and its circumference is 2 pi r centimeters. Now think, among all of these expressions over here, what are the common characteristics So now let's do some concept learning. In the calculations above, the operations between numbers and variables are all linked together with multiplication. Both represent the product of variables and variables. Such formulas are called monomials, and a single number or variable is also a monomial. So make a note of that. A single number or variable is also a monomial. The definition of monomials are numbers and variables linked together with multiplication, or a single number variable. For example, like -2, a, -b, -1/3, etc. are monomials. No, like 1 plus x, 1 divided by a, b over 2a, etc. are not monomials. So take a moment to think about that. Why are these examples not monomials? I'm first going to leave you with that, and I want you to keep you wondering, and we're going to uncover that later on in this lesson. So now let's just do some practices. Which of the following are monomials? Pause the video and figure that out yourself on a sheet of paper. Well, the answers are, the first one is monomials, so the second one is, so is the fourth one, 3.14 is, -m, and that's it. So now here's the method summary. The method of judging monomials, whether it is a monomial or not a monomial. 1. A single number or variable is a monomial. This is a very important key point that you would probably want to pay lots of attention to. So 1. A single number or variable is a monomial. 2. Does not contain addition or subtraction, and monomials only contain multiplication within them. 3. There may be one or more monomial numerical factors and variables. 4. It can only have known value divisors. It can never contain variables as divisors. So that's an important part there. It has to have a divisor if it is dividing as a known number, not a variable. So that means that 1/5 would qualify as a monomial. But 1 divided by x would not be a monomial because the divisors, one is a known value while the other is an unknown variable. So that's a very important part there that I want you to jot down, because many people, they forget this rule and they forget that this is not qualified as a monomial. So pause the video and take a look at all of this again and try to memorize them or understand them. Okay, so let's move on. Think. What are the meanings of variables and numbers in monomials? So here's a monomial, 6a squared. Over here, the number part of the monomial, which is the 6, is called the coefficient. Repeat after me. Coefficient. Over here, the a, which is the variable part, is being raised to a power. That power is the second power of a. And since that second power, that exponent, is the only exponent in the monomial, that is considered the degree of the monomial. Here's another example. This 1/5 is the coefficient. This is just raised to the first powers. Those are the raised to the first power. So it might seem like, well, there isn't any degrees there. It's 0. No, it is 1. So 1 plus 1, that would be 2. So the degree of the monomial would be 2. Remember, the degree of a monomial is always going to be the sum of every single exponent there is in the monomial. So definition. In the monomial, the number and variable are being multiplied, and the number factor is usually called the coefficient. It is called the coefficient. And the sum of the exponents in all of the variables is called the degree of a monomial. That was a lot of key terms right there. So I'm going to repeat it again. First, the number part. What is that called? The coefficient of the monomial. Jot that down. Coefficient is equal to, and then its definition. Next, the degree of the monomial. Degree is equal to definition of degree. The degree is the sum of all of the exponents in all of the variables in that monomial. Now over here, this shows something really interesting. When you see a monomial like negative AB divided by 5, really the coefficient is a negative 1/5 right there. Because negative AB divided by 5 is the same thing as negative 1/5 times AB, negative 1/5 AB. These are the equal thing. That means that the coefficient is negative 1/5. Now let's do some examples. Write down the coefficients and degrees of the following monomials. The answer is the first one. The coefficient is 3, degree is 1. Second one. The coefficient is pi. Remember, pi is not a variable, pi is a number. Instead, the symbol for pi looks kind of like a variable, but it is a number. The coefficient is pi. The degree is 2. Third one. Coefficient is 1/7, negative 1/7. Degree is 1. Coefficient is negative 2/3. Degree is 3. Fourth one. The coefficient is 1. Degree is 4. Last one. The degree is 3. The coefficient is negative 1. Did you get all of these right? Sometimes people get easily fooled when they think, well, this A doesn't have an exponent there. It's not written. That means it's a 0. No, the definition of a power being 0, most of the time, that is always going to be 1. So usually you would just say that this one has a degree of 1 because 1 is just not written. It can be omitted. So is the same for this one. There is no coefficient there, but really there is. 1 times any number is always going to be that number itself. So the coefficient would just be 1 because that can be omitted. If you ever see another one like, say, negative A divided by 7, that would just be the coefficient, negative 1/7. Okay, let's move on. Did you get everything? If you didn't, always remember to go back and re-watch that part. Example 2. Fill in the blanks with monomials and indicate their coefficients and degrees. So I'll leave the problem reading to you, and then once you're done filling in all of the blanks, you can unpause the video and then come back to me. Are you done filling all the blanks? Great. So the first one. Every book series has 12 books. So n book series will have 12 n books. There are n book series. Each book series has 12 books, so there's 12 n books. 2. What is the area of a triangle? Knowing that the height is h and the width is a. I'm sure you remember how to calculate the area of a triangle. It's always going to be the width times the height divided by 2, or times 1/2. So that would be 1/2 AH. 3. The length and width of a cuboid is 2a. The height is h. Then its volume is 4 squared h. 4. The original price of a TV set was $8, and now it is sold at a 10% discount to the original price. The current price of the video camera is blank. Oh, excuse me. I meant this to be a TV set, so TV. Okay, so we already know that it has a 10% discount. But really, it's not you're buying it on 10% of A. It's just minusing 10% from A. If you minus 10% from A, you're left with 90% A. So that would be the same as 0.9A. 5. A rectangle has a length of 0.9, a width of A. So the area is going to be width times length. That would be 0.9A. The coefficients are going to be 12, 1/2, 4, 0.9, 0.9. And the first one is raised to the first power, the degrees, second power, third power. And look, the same formula can have different meanings. It's very important when you're asked to describe the meaning of a monomial or polynomial during a word problem. The same formula can have different meanings. That would be first power and first power. Now that we've mastered most of the key points in the concept, let's move on to some practice exercises. So the first one is determine whether the following statements are true. I'm going to leave the reading to you and then unpause the video when you're ready to come back and check your answers. Alright, so the first statement is the coefficient of negative 7xy squared is 7. Is that true? No, because the coefficient of negative 7xy squared is negative 7, not just 7. You don't have to just look at it's not just the number part. You always have to look at the symbol too, and that's negative 7. 2. Negative x squared, y cubed, and x cubed don't have coefficients. No, they have coefficients. It's just that it's negative 1 and 1, and they can be omitted. 3. 0 plus 3 plus 2 is the degree of negative a, b cubed, and c squared. Now be careful on this one. It's that same trick again. It's trying to tell you to think that a is risen to the power of 0. But really, a does have a coefficient. It's just 1, so it could be omitted. Don't miss the power 1 of a. 4. The coefficient of negative a cubed is negative 1. Yep, that is definitely true because it can just be omitted. Negative a cubed is always the same thing as negative 1 times a cubed. 5. The degree of negative 3 squared x squared y cubed is 7. You have to keep this in mind. The degree only ever counts the exponent of the variables. So don't ever look at the exponents of the coefficient because that never counts. -3 squared is the coefficient, not any variable part. And the last statement. The coefficient of 1/3 pi r squared h is 1/3. Nope, that is not true. Mostly because pi is part of the coefficient and might blend in as any other variable, but it is a number. It's part of the coefficient. It's just that the number is way too long for us to describe in real numbers, so we have a symbol for that. In conclusion, the coefficient of the monomial, the digital factor in the monomial. So the definition of a coefficient is the number part of the monomial. If a monomial contains only variable factors, then its coefficient is 1 or -1. If the monomial is a single number, then the coefficient is itself. 2. The degree of a monomial should be the sum of the exponents of all variables in the monomial and has nothing to do with the exponent of the coefficient. For example, the degree of 24x squared y cubed is 5, not 9. And the degree of a constant term is always 0. And okay, over there, you might be confused about what a constant term exactly is. But a constant term is just a term that has no variable parts in it. It's just, say, 5, -123. Those are considered constant terms because the value is constant. It is not varying as a variable would be. And 3, don't think of pi as a variable. That's some of the mistakes students can make. Pi sometimes, well, you might think it doesn't have any normal digits in it, so you might think of it accidentally as x, y, z, a, b, c, like a variable. But really, pi is a number. Pi is part of the coefficient when you see it in 1. Now we're going to take a look into some related concepts of polynomials and monomials. So let's first do some problems. Here is 4 word problems that I want you to do by yourself first and then unpause the video to come back and check your work. So the first problem. After the temperature drops by 5 degrees Celsius from 2 degrees Celsius, it is blank degrees Celsius. Well, it drops, there's a key word there. Drops by 5 degrees Celsius from 2 degrees Celsius. So it drops some degrees from some degrees. So then it's going to be T minus 5 degrees Celsius. Next, a basketball is worth X dollars, a volleyball is worth Y dollars, and a soccer ball is worth Z dollars. Then 3 basketballs, 5 volleyballs, and 2 soccer balls would be worth 3x plus 5y plus 2z dollars. 3. The area of the triangular shape below is blank. Well, how we could do that is we first figure out the whole area of that triangle, and then we subtract the area of that circular hole from it. Then that would just be the blue shaded part. And that would be 1/2 AB minus pi r squared. 4. The picture below is a floor plan of a residential area. The floor area of the house is blank meters squared. We could just add up all of these smaller areas together. That would give us x squared plus 2x plus 18 meters squared. Now we have some discussions. Looking at these algebraic expressions up here, ask yourself, are they monomials? What are the characteristics of these formulas? what is the relationship with monomials? Look, so over here we have 1/2 AB minus pi r squared. And this shaded part over here, 1/2 AB is a monomial. So is negative pi r squared. That is also a monomial. So it seems like these algebraic expressions are made up with multiple monomials. This is monomial plus monomial. Remember, you can think of this term as a whole. The formulas above are all forms of two or more monomials. Interesting. So it's two monomials hooked together by some sort of operation. Addition or subtraction, it seems. So let's learn the concepts. Polynomial related concepts include 1. The sum of several monomials is called a polynomial. Be listening carefully as I read these, and you may want to write them down. 2. In a polynomial, each monomial is called a term. Make a note of that. 3. Terms not containing variables are called constant values. 4. The degree of the highest term of the polynomial is the degree of the polynomial. These are using many concepts we learned from monomials, but it kind of has a different meaning, it has a twist in there when it comes to polynomials. So basically, a polynomial is made up with many different monomials or terms. Okay, so there's terms in a polynomial, and the degree of the highest term of the polynomial is the degree of the whole polynomial. So remember that, okay? There is definitely a difference between monomials and polynomials. Polynomial could be an example of 3x cubed plus 5x plus 8. A 8 is called a constant value because it does not contain a variable within it. And 3x cubed has a degree of 3, and that is a degree of the whole polynomial. Example 3. Which of the following expressions are monomials? Which are polynomials? Find the coefficient and degree of the monomials and polynomials. I'm sure you got all of these right. And if you're confused about anything, you probably want to go back to when I was talking about the concept. Or you may even want to go all the way back to monomials. So try this problem. I think you got it. You should. But if you didn't or are confused, go back and rewatch. And then we'll be moving on. So this is our analysis here. We're organizing all the knowledge and concepts we have so far about monomials and polynomials. Our first monomial is negative 1/2 a squared b. So the coefficient would be negative 1/2 and the degree would be 3. Then we have m to the 4th power n squared divided by 7. The coefficient would be 1/7. Remember, just hidden right there. And the degree would be 6. Next one. Monomial x, coefficient 1, degree 1. 32t cubed, coefficient 32, degree 3. Last one. Pi divided by 3. There is no coefficient and the degree is 0. Remember, this is a constant term. Now let's move on to polynomials. First one, x squared plus y squared minus 1. Terms are x squared, y squared, and negative 1. Degree 2. Another polynomial. 3x squared minus y plus 3xy cubed plus x to the 4th power minus 1. Terms are 3x squared, y, 3xy cubed, x to the 4th power, and negative 1. Degree 4. Last one. 2x plus y. Terms 2x and y. Degree 1. So the key points are now summarized for you. Take a close look at this. This is a summary of everything we learned. 1. The terms of the polynomial should include the symbols in front of it. 2. Polynomials have no concept of coefficients, but each term has coefficients. The coefficients of each term includes the preceding symbols. 3. To determine the degree of a polynomial, first determine the degree of term in the polynomial, and then find the highest degree. 4. The highest order term of a polynomial may not be unique. Example 4. Known that negative 5x to the nth power plus 10 risen to the fourth power x to the nth power plus negative 4x to the nth power y squared is the sixth degree polynomial of x and y. Find the value of m and rate the polynomial. So here's a solution. From the problem m plus 2 equals 6, the answer is m equals 4. Because the polynomial is this, the answer is 4 because the polynomial is this. Okay, so let me explain that more. It's saying that this polynomial over here that you see is the sixth degree polynomial of x and y. So that's using one of the concepts we learned earlier on. The sixth degree of polynomial of x and y. It means that the highest degree of this polynomial is 6. We need to figure out the value of m. Well, it already told us that the degree of the polynomial is 6. So it seems like we can't get anything useful from these first two terms. So let's just look at the last term, negative 4x to the nth power y squared. Only this can be the highest degree of this polynomial, because over here it's just m and this is m plus 2, so this is definitely larger than that. And this is also just x mth, remember this does not count, but this is m plus 2, it's also larger than that. Basically, now we have a quick conclusion. The degree of this is going to be larger than both of the degrees of these first two terms. So now we know that the degree of the whole polynomial only looks at the degree at the monomial with the highest degree. And we know that this is a monomial with the highest degree. And it says that the polynomial is on its sixth degree. So we have to know that the exponents up here, m and 2, added together would have to equal 6. Well, what plus 2 equals 6? 4 plus 2 equals 6. M equals 4. And that is the answer. M is equal to 4 just by having the basic concept engraved in our minds. This was testing and practicing the concept of degrees of the polynomial. So if you were very confused on this one, go back and re-watch the concepts, or else you're not going to understand anything further down this video. Also, after that, remember to come back and re-watch this solution, or maybe you want to solve the problem again by yourself. So if you're confused, go back. If you're all set, move on with me. So here is another problem on a slightly harder level. If the polynomial negative 5x cubed minus mx squared plus n minus 1x minus 1 to x does not contain the second and first power terms, find the values of m and n. Pause the video and do that. This is a slightly harder problem, but I would encourage you to challenge yourself and try to do it. Okay, did you get an answer? Did you try? Were you confused at something? So let me go over that again. The key point here is the polynomial does not contain the second and first power terms. What does that mean? Saying any polynomial that has a degree of 2 or 1 is not included. What does that actually mean? Well, if it's not included, that whole term should be equal to 0. Look, it's being multiplied together, and we know that if we want to get rid of some sort of term, we need to make one of the factors be equal to 0, because 0 times any value is going to be 0 itself. So that makes n minus 1 equal to 0. That way, this whole term could be gotten rid of. So that makes this whole term disappear. But look, there's another key point here. If this equals 0, what is the this? This is n minus 1. So that means n minus 1 is equal to 0. If n minus 1 is equal to 0, then n itself is equal to 1. All right, everyone. Now here's do a activity. 1. The polynomial x squared plus y minus z is the sum of the monomials blank, blank, and blank, which is a blank degree polynomial with blank terms. And 2. The polynomial 3m cubed minus 2m minus 5 plus m squared contains the constant term blank, its second degree term blank, and the coefficient of the second degree term is blank. So pause the video and fill in these blanks by yourself and then unpause to check your work. So the first one has the answers x squared, y, negative z. Remember, over here when we are minusing this z here, don't think of it as you're minusing a z. Think of it as you're adding a negative z, because adding a negative number is basically subtracting that negative number's opposite number. So that is a rule you probably learned from chapter 2, and that should be sticking with you. So it is a second degree polynomial with 3 terms. Its highest degree is a 2, so that would be the degree of the whole polynomial, and it has 3 terms. 2. So this is a problem. And it has a constant term, negative 5. Remember, a constant term is the term or any term in a polynomial that does not have a variable factor. And its second degree term is, well, what's the second degree term? What's the term that has a degree of 2? M squared. So that would be m squared. And the coefficient of the second degree term is, well, what's the coefficient of m squared? 1. That is just omitted. Now we're going to do some problems with polynomials. So example 5. As shown in the figure, use a formula to express the area of the ring. When r equals 10 and r equals 15, find the area of the ring. Take pi as 3.14. So the ring here would be this shaded in light blue area. So pause the video and figure that out. This shouldn't be too hard, right? You could just list the formula and then solve. So the solution is to first find the area of this whole large circle and then subtract the smaller circle from it. And then that would give you the area of the ring. So that would be this answer over here. Did you get it correct? Probably did. But if you didn't, go back, check your calculation. Or was it the formula you listed was wrong? So remember to definitely fix that and then you can move on. That would be the formula. But when r is equal to 15 and the second r is equal to 10, we can calculate, and that would be the answer is 392.5 centimeters squared. Example 6. The decorations of the windows in Molly's and Alexa's rooms are shown in the figure. They're composed of 2 quarter circles and 4 semicircles, the same radius, respectively. 1. What is the area of the windows where sunlight can enter? 2. Can you see the monomial or polynomial used to solve? What are their alike features? Look, over here, this is the area of the windows where sunlight can enter. It's first this whole rectangle, and then you subtract the area of the curtains. This isn't really good, but I think you get the idea. So they all have multiple variables, and the degrees are both 2. Now here is another doing activity. 1. A, B respectively represent the length and width of a rectangle. Then the perimeter of the rectangle is, and then you have to fill in all of these blanks. Pause the video and do it. So this is the perimeter, and if you were confused, just pause the video again and then do it, okay? I'm sorry, but this is now you know the perimeter. Okay, you came back, right? So the perimeter would be 2 times the sum of a plus b, or 2a plus 2b. They're all the same thing. So then the area would be, and remember over here S is the area, the S would be equal to AB. But then when A is equal to 2 and B is equal to 3, L would be equal to 10 centimeters. Remember, all you have to do is fill them in, plug them in into their original variables, and the area would be 6 centimeters squared. Second problem. A, B respectively represents the upper and lower sides of a trapezoid, and H represents the height of the trapezoid. Then the area of the trapezoid S would be equal to blank. And then over here it gives you all the values that it could have, and then you have to solve it again. So I hope you remember how to calculate the area of a trapezoid. That would be 1/2 times the sum of A and B times H. So that's the answer. So if you forgot, you can go to a video that we made from Inquisitive Kids and another recorder, which is Kaylee. She made a video on that specifically, so you can go ahead and watch that after this video maybe, or right now. And then after, you can come back. So that's the answer for the first one. And all you have to do now is replace all of these values in, and then the area, or S, would be equal to 15 centimeters squared. Now you have the concept in handy, so let's use that and have some practice in class. 1. Which of the following formulas are monomials? Which ones are polynomials? Which are expressions? 2. Determine whether the following statements are correct. 1. Polynomial negative x squared y plus 2 minus y has a degree of 2. Polynomial negative 1/2 minus a minus 3a squared has 1 as a coefficient of the first degree term. 3. Negative x minus negative x minus y minus z is a third degree trinomial. So the first one, it's asking for us to identify which ones are monomials and which ones are polynomials. Well, monomials is just one term, but polynomials is linked together and made up of several terms. So this 3x, negative ab, and negative 5 are monomials, while 2x minus 1, m plus 1 divided by 3, and 3m minus 4n plus m squared n is polynomials. And 2. The first statement is incorrect. And that's because the monomial with the highest degree is not 2. It's actually negative x squared y here. The y actually is raised to the power of 1. So that would be 2 plus 1, which is 3. And the second statement. So the statement is that polynomial -1/2 minus a minus 3a squared has 1 as the coefficient of the first degree term. Let's first find which one is the first degree term. Well, -a is the first degree term, but -a has -1 as the coefficient of it. So no, that is also incorrect. Third one, it's saying that it's a third degree trinomial. Well, yes, it is a trinomial. It is made up of 3 terms, but it is not 3-degreed. So that is also incorrect. And now we have a class summary. We learn all about monomials and polynomials. So first, in the concept of monomials, we learn about coefficient, numerical factors of monomials. Maybe you want to organize all the definitions you had on from earlier and organize them into this kind of diagram. Degree, the sum of the exponents of all variables. So that's for monomials. And now let's take a look at polynomials. Polynomials, term. Each monomial in the polynomial is called the polynomial's term. That doesn't contain variables are referred to as constant terms. And degree, the degree of the term with the highest degree in the polynomial. So all we have to do is find the term with the highest degree, and that would be the degree of the whole polynomial. And these together are called whole expressions. Monomials and polynomials, whole expressions. And our lesson summary is: first skill, understanding the concepts of monomials, polynomials, and integers through specific examples. And 2, understanding the concepts such as the coefficient and degree of monomials and the degree of polynomials. So again, I have to keep saying that you have at the key points where you were supposed to jot them down. I hope you did all of that, because later on you will be needing to use their notes. Also, if you are watching this video, please give us a thumbs up, subscribe if you haven't yet, ring the notification bell, add a comment, like, or better yet, share it with someone you know. So thank you for you watching our videos, and lesson 5 will be coming up soon. I hope you stay on the lookout for our next video. And remember, if you don't know how to calculate the area of a trapezoid, we have all of those figured out in a video for you, made specifically by the other recorder, Kaylee. So be sure to check out her video, and then that will probably make a lot of sense. She does a really good job explaining. So after you watch her video, you're all set. Just remember to share, subscribe, notify. That's it. And if you want to visit our website, click the link down in the descriptions below, and we'll see you next time.